For any AI solution to succeed, one thing is non negotiable: high quality data. And the heroes who handle this data, pulling it from the right sources at the right time and in the right format, are the data engineers. But there is a rumors going around. The AI is coming for their jobs. No, I don't believe AI will replace the data engineers entirely. But I'm certain about this. A data engineer who masters the generative AI will absolutely replace the one who doesn't. That's exactly why we created this series, Generative AI, every data engineer should know. Our goal is to equip you with the skills you need to thrive in the new era. We will break down the core role of the data engineers and pinpoint exactly where generative AI can revolutionize your day to day activities. We are here to show you how to empower your work, making you faster, smarter, and more valuable than ever. I am confident this will be incredibly useful to you. Let's dive in. This is Generative AI, every data engineer should know from Data and AI Express channel. Let's get started. First, look at the typical day in the life of a data engineer. Their world revolves around building and maintaining the data pipelines. They tap into a multitude of source systems, be it OLTP or OLAP databases, various operational stores, or external data feeds from APIs, or numerous data sources using ELT, extract, transfer, load, or ELT, extract, load, and transfer methods, tools, and processes. They extract this raw data and load it to central repository, which today is often called cloud-based data warehouses or a data lake or data lakehouses. From the central hub, the data is then refined, transformed, and organized into domain-specific data marts. Think separate, optimized stores for finance, supply chain, or product use. Finally, this curated data is served up to the reporting layer, powering the dashboards and analytics that business users rely on. In essence, data engineers build the entire super highway that transport raw data and turns into actionable insights. But here is the reality. Where does most of the data engineer time actually go? It's all spent deep in trenches of coding. We are talking about maintaining massive code bases, sometimes with millions of lines of complex SQL or Python. And the real time sync isn't writing new code from scratch. It's the endless cycle of rework, debugging, and enhancements on existing pipeline that consumes the majority of the day. They often become what I call a code archaeologist, constantly digging through complex SQL queries. It's a tangled web, maybe written by a producer or even by themselves a month ago. The logic is convoluted, intermediate outputs aren't visible, and they are focused to manually trace the data step by step just to figure it out. Where did the value go wrong? What specific changes is the business user even asking for? Pinpointing the exact source of an error became a massive time drain. And here is the killer: a documentation is always outdated or non existent. The original developer might have scripted something down under the tight deadline, but over the time, as the new people make changes, the documentation is left behind, becoming a useless and misleading relic of the past. So, when a stakeholder comes and knocking with the seemingly simple question, hey, can you quickly check the logic of the metric? It triggers a painful forensic investigation. That one quick question forces the engineer to dive into maze of tables and scripts, spending hours or even days just to reverse engineer the logic. This ad hoc reactive work where productivity goes to die, and finally they ended up adding one more patch to the existing pile of code. This brings the true reality. Many data engineers spend 80% of their time on low impact repetitive tasks. debugging, testing, manual rework. That leaves only a tiny 20% of window for the meaningful strategic work they were actually hired to do, like designing new systems and innovating. This is where generative AI comes into flip the ratio into the other head. Let's see how. First up, data discovery. Instead of manually haunting through databases, you can ask GenAI assistant in natural language, find all the tables containing customer transaction data. Next, accelerator pipeline development. With AI powered IDE, you describe your code. This is my sources, this is my target, and here is my logic. And the AI generates the entire pipeline for you, whether it's a SQL, Python, PySpark, or any other languages for that sake. Think about data modeling and schema generation. This is a game changer. You can provide a few sources of table and describe the business domain like create a sales order data model for the supply chain. The AI, using its understanding of common data pattern, can generate a logical and even a physical data model for you, cutting down the entire development time significantly. It can even analyze an existing data model and suggest improvement or expansion based on the new requirements. This can reduce the manual effort of data modeling by at least 40%. It can generate logical data models, physical models, and even architectural diagram to go with them, streamlining the entire designing process. For the complex tasks like data architecture and modernization, GenAI acts as a powerful co-architect. If you are migrating a legacy system or re-architecting a new technology, you can feed the AI your current architecture diagram and goals. It will help you to plan the migration strategy, identify the dependencies, and even generate the transformation scripts. It dramatically accelerates any transformation program. Other key areas include code development with the tools like GitHub Copilot or AI IDs. Code conversion, for example, translating Python to SQL or SQL to Pandas or any code conversion becomes very simple. Automated testing and deployment optimization for both storage and code, data governance and compliances. The applications are truly endless. You might be thinking, wow, that's a lot of areas. If you have been sticking to the old ways, struggling for days on a problem that could have been solved in minutes, it's a time for change. The urgency is real, very real. Why now? Because today's AI models like Gemini's, OpenAI, GPT-4o, and other models have become incredibly mature, and we can now start adapting to these AI tools in your nodes. Their ability to understand the context, reason through the complex logic, and generate accurate code has improved exponentially. They can understand the nuances of your businesses and provide relevant context-aware solutions. The time to trust AI as a reliable co-pilot is now. Furthermore, we are seeing seamless tools integration. Every major data platform, whether it's a Databricks, Snowflake, Google BigQuery, or Informatica, is embedding powerful AI assistants directly into their products. The Databricks Assistant and the GitHub Copilot are just the beginning. Within a year, AI capabilities will be shared features in every tool you use. With the vast volume of data we are handling today, manual methods are no longer sustainable. The sooner you adapt to generative AI, the bigger your advantages will be. Early adopters will gain a massive edge. Just look at the landscape of open source tools for the data engineering. It's impossible to master them all, but AI can help you to guide through this complexity. You can pause this video here to take a closer look and do put it in a comment which tools are currently used by you. Let me show you a few concrete working example of how you can apply this right now in your daily activities. First, in the planning and architecture phase, this is a really a low risk area but high reward area too. Think of GenAI as your personal whiteboarding partner. You can use it to generate architectural diagram or brainstorming different ways to design your application, helping you to build a solid foundation faster and reliable. Now for coding and SQL generation, this is where you will see massive time saving. Here is an example from a database system. I just wrote a prompt in plain English, generate a SQL query to calculate the total sales revenue for each product category by month. And look at this, it instantly generates a clean, accurate SQL query, complete with joins, aggregation, and filtering. I can just copy paste into the system and run it. But let's take a step further. I then asked, now, can you convert the same logic into a PySpark script? And voila, it instantly refactored the entire logic into a multi-line PySpark program, correctly using Windows function and the data frame operation. This conversion would have been significantly manual effort. The code is clean, efficient, and ready to deploy. It even created a ranking using window function. This is the power of AI system development. Here is another example. I gave it a Python function and I asked, can you optimize this function? I specifically requested it to be improve the time and space complexity. It immediately recognized the opportunity to use a technique called memoization to cache results. It explained the technique and provided the optimized code, transforming a potentially slow recursive function into a highly efficient one by adding a simple cache mechanism. What about debugging? I took a large SQL query and intentionally introduced an error. I forgot the sum aggregation in the having class. I asked the AI to fix it. Without this, I could be staring the code for ages. But the AI immediately identified the error and provided the corrected code, explaining exactly what was wrong. Imagine this with a 1,000-line query. Beyond coding, we spend or should spend a lot of time on testing and documentation. For testing, you can simply give a function to a GenAI tool and ask, can you create a test case for this function? It will generate them for you, covering the boundary conditions and the edge cases you might be missing. You can even ask it to generate large volume of synthetic test data. And as for documentation, the pain is over. Just paste your code and ask it to summarize the logic. It will generate a clear, concise documentation automatically. Here, I asked it to generate 30 sample entries for a test table in PySpark, and it wrote the code to create and load the data instantly. Look, it has beautifully created a table named test underscore gen underscore data and loaded all the records as requested. You can use the LLM not just for your day-to-day work, but also to learn new technologies and prepare for interviews. It's like having a personal tutor. I remember an interview a few years ago at a major bank where they have asked me, can you design a data model to calculate the monthly minimum balance fee for customer accounts? Today, you can ask an LLM exactly the same question. It will break down the problem, suggest the necessary fact and dimension table, and explain the logic. It's having a personal interview coach available 24/7. But think bigger. We are now seeing the rise of AI-powered pipelines. This is not just about using AI to write the pipeline, it's about embedding AI inside the pipeline. Imagine a data pipeline that processes customer feedback from multiple languages, You can now make an API call to the model like Gemini or OpenAI directly from your Python script to translate all the text into English in a real time. You can make a call to an AI model, get the output, and store the results directly into your data warehouse. We have seen how generative AI is transforming the role of a data engineer. It's empowering you to move from repetitive tasks to highly impact and strategic work. I hope this has given you a clear vision of how you can elevate your skill and your career to the next level. You should keep the AI in your pocket and move on with the pride. If you have any more questions, please leave them in the comments below. If any topic you want me to take it forward in a separate video, please put it in the comment section. Thank you so much for your support. I will see you in another interesting video from Data and AI Express, your data and AI companion. Thanks everyone.